So thanks for last day. So the tradition at the summer school is to do a sort of workshop at the end where we get a bit more focused. And today we're doing a workshop on approximations in Gaussian processes, advances in approximate inference with GPs. I think this is an important area, and it's one like, if you go back, I think the first GP thing we did in Sheffield was 2005. Gaussian process roundtable, and a lot of that was dominated by approximations and some of the things that Rich Turner very clearly explained yesterday. Then I couldn't quite fit this on the screen, but there was this great thing on Twitter. All right, team, if you want to be taken seriously by the research community, you need to come up with some theoretically driven research projects. And I'll have to now move to my browser when find it on Twitter, which is going to be a little bit awkward from. Okay, I know what I'm going to do. I'm going to do it on here and then project it back up. I just thought this was funny that it came out during the probably won't be funny if it takes me 3 hours to actually pull it up. But it came out during the workshop, so someone just, yeah, so let's pull that version up. So this is what's going on. Things are crazy at the moment in the field, according to me. So if we want to be taken seriously by the research community, we need to come up with some theoretically driven research projects. And then, so this is a cartoon that someone's photoshopped. And so one model to rule them all. I don't know. It's just, I don't know. I think that's such a silly premise. Outrageously large neural networks. And then the person on the end says sparse Gaussian processes. And then that's kind of where we are, seemingly, with respect to the wider community. So someone put that on Twitter. Actually, I said, I want that framed. So the guy who did the Photoshop editing, he's coming up to Cambridge. He said he'd print me a copy and frame it for me. So I'm looking forward to that. Okay, so what I want to talk about a little bit is, I like the historical perspective. And does anyone here know what I think they pronounced it the Ratio Club, not the Ratio Club. Does anyone know what the Ratio Club is? So Rich does. Yeah, good boy, good lad. Anyone else? Very sad. So I guess in the late 40s, Wiener published the book Cybernetics, which I would trace to this sort of founding of well, some people trace to the founding of artificial intelligence. And I think what was going on, if you try and reconstruct, that a lot of people have been involved in war work. And in the UK, for example, you had the sort of work at Bletchley Park, which became GCHQ, where they were trying to decode. So that's sort of, they were building machines that were making decisions. And you also had radar work, which was like sensing work. So people were looking at things to try and sense and respond, detect things. And I think that this made, the people that were doing it were people that moved into war work from academic backgrounds. And some of them were quite young and given very interesting jobs to do. And the Ratio Club, it's got meetings. It didn't write much. It's got some informal meeting notes that are collected. So I was looking through some of them. And it was a collection of these people who I think their founding, this is so British, their founding charter was something along the lines of the people who had the ideas in Wiener's book before Wiener did, or something like that. So he wrote a book about it, but of course we knew it was all. So it was a sort of British club of cyberneticists who all went on to become sort of massively famous in their own field. So the only one who was still living is Horace Barlow, who's, I guess, a neuroscientist. And Alan Turing was in it. And my personal favorite was Donald Mackay, who's the father of David Mackay, who, and some of them, so Alan was obviously in, I don't know if Jack Good was in it, actually, or just peripherally involved, but was involved in war work. Anyway, they had this club, and it was really about discussion of artificial intelligence type ideas. And what really happened to those ideas is they became very specialized in different fields. They found the formation, cybernetics became very closely associated with control. And the bits of it that worked are kind of standard today. They're not even considered AI today. So, but the approaches they took all led them to be very famous. So that's not really got much to what I want to suggest next, but I think that we need to start the Spatio Club. Now, what do I mean by this? In some ways, I'm really excited and super disappointed by progress in Gaussian process approximations. the premise of these models, as we've sold it across the last few days, and hopefully you're fully indoctrinated, is the creativity you can do. I mean, look at what Archie was telling us about yesterday, where he was showing these wonderful models of forecasting. You can decompose into these parts. We had that little discussion where I asked about why does he care about identifiability, and the answer is interpretability. And these are very powerful approaches to doing that, bringing in non-parametric components to decompose complex signals into things that you can talk about. I mean, to actually sort of show, hey, look, birth rate goes up on, was it going up on Valentine's? And, goes down at the weekends. All these sort of things that you wouldn't sort of necessarily be able to see unless you decompose. Questions over modeling, Rich said, well, is it really the right? Yeah, sure, we can do all that. Very creative. But then the challenge is that, Rich gave a wonderful introduction to some of the approximation methods we have. But the real problem is this disconnect between our capability to use these models at their full functionality and approximate them for millions of data points. So you'll hear people just offhand say, yeah, we can do millions of data points. Yeah, we can. We've done that. People have methods for doing that. But what they don't say is in specific circumstances where we have particular covariance functions or particular input dimensionalities. And what we find, for example, with GPy, which is designed from the ground up to be a sort of accessible way of starting to do these models, to pull them together so that people can just rely on GPy for doing the underlying model. And people love it, and then they email us saying, oh, but now I want to do 50,000 data points. So this is great, and I've got some really good results, but now I want to scale it up to 50,000 or 1 million or something like that. And often the answer is, well, now the approximation you need is kind of super dependent on the underlying model you choose. So you suddenly have to go from this zone of like in the neural network world of a 3-liner complex model, which you then just deploy on data, to suddenly having to have an in-depth understanding of the different approximations, where they can be used, et cetera, et cetera. And this whole illusion that you've got some creative framework just disappears. And I'm really getting tired of people coming up with approximation methods and not acknowledging that. There's a sort of industry of people producing approximations that say, oh, I can now do it in this space, and look at this amazing idea I've had, and blah, 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 blah. And, oh, this works for this particular covariance function under these particular circumstances. And I think, certainly Rich, who's here, and other people amongst us are sort of feeling, well, there's a big challenge. So it's great if you can do time series, for example. But the nature of the approximations you need for time series, Simo, who was speaking the other day, has really led the way on that. Rich also has some great approximations on that, are very different from the ones that work spatially. Why? Because spatial approximations, typically your space is bounded. You might have some, but time just goes on forever. So the way in which you choose to approximate, you might want these sort of Markov style approximations in time, but in space, we typically end up using these inducing points. Or people use compact covariance function support, or people start suggesting Fourier methods. We don't even need to do deep things to make Gaussian processes more widely acceptable. We don't even need to do cool, deep Gaussian process models, which are great, and I'm enjoying the approximations people are coming up with those. But just basic spatiotemporal modeling at scale is out of our reach. So if you just want to model the whole of Twitter, and you model like sentiment across the whole of Twitter, spatially and temporally, and you want to take the whole of the feed, you can't do it with a GP because the nature of the approximation you need spatially is different from the one you need temporally. And combining them together is very challenging. You have to be very expert in what you're doing. And typically, what you would want to do is just write down a very interesting covariance function, approximate, but you end up being hamstrung by your future approximations in the class of covariance functions you use. So basically, you're not getting this separation. I mean, I don't fully believe it can ever be done, the separation of model and algorithm and the separation of sort of model and decision making. These are the clean separations where we try and decompose. They can never be cleanly done. But the promise of doing things in the way that we've said, work out your model, then think about your data, blah, blah, just doesn't exist if you have this then later job where you have to think algorithmically and it screws up your model. So we're telling you a lie unless we fix that, right? So I just wanted to use this welcome to sort of point that out and sort of say, yes, people can do millions of data points. Yes, there's some interesting approximations out there. But the thing that we're missing two things. One, we're missing good software to do this at scale, and that's something I'm much less interested in publishing new algorithms at the moment. Maybe people in my team are like, what? I'm much more interested in producing the software that allows other people to explore this space, because that's what we've seen has been very successful in neural networks. That what you need to do, what is it? How many monkeys doing typewriting to produce Shakespeare, right? Now the community aren't monkeys, but but also we haven't produced a typewriter yet, So at the moment we've got a couple of chimps working on these things that can do it in certain ways. And what we're really seeing, the success of deep learning is really numbers of eyes on the problem and the ability of the toolkit to deploy very quickly. So I think that's where there's an enormous gap. And a lot of that really involves the engineering side, not so much a lot of the things that we're seeing are just extensions of known things. And I think we should be identifying that and calling that out and saying, well, rather than publishing that, why not work on actually showing it working across a number of cross-sections and the real challenges, which are these spatial-temporal models. So I wanted to use my introduction to sort of say that I'm depressed, and that's why. But it's going to be all right, because we're going to form the Spatio Club, or the Spatio Club, I think we should call it. I don't know, it's missing the temple. It's sort of totally bizarre now, but I just wanted to map to the Ratio Club. And people, anyone, you could join the Spatio Club if you just agree with what I said. Then you're in the Spatio Club, and I don't know, there'll be a Facebook group or something like that. So I think one thing I find important, you have to have words to recognize. So there it is. The Spatio Club is the group, doesn't care about cybernetics, it just cares about practical Gaussian process approximations that don't constrain you in the deployment of your model, that allow you to do the full expression of the modeling framework, and then not worry about what's going on inside the box. But we're not there yet. We're a long way from there, which is a bit depressing. Okay, so that's my intro. I'm a little bit over. So who's the first speaker? Alan. So having said that, I think, Alan, you're going to talk a bit about you want more review of the sort of old work around the non-Gaussian approximations, because I guess that's something we didn't cover in the summer school. So just to sort of contextualize some of the things. So I think that this, broadly speaking, approximation work in GPs historically was in two directions. I'd now say three. The two directions were historically, you want that one, don't you? Sorry. You've got to pull that off. My thing doesn't plug into yours. Would be non-Gaussian likelihoods, and methods like EP, and that's what Alan's going to talk about today. Rich already spoke a lot about sort of related methods, but then with a different idea of speeding up Gaussian processes. I'd say the new area that we're seeing is like deep Gaussian processes, which can be viewed as very complex non-Gaussian likelihoods, but I think that they're class